You're not going to want to miss this episode of the AI Show where we talk all about next generation computer vision capabilities with Project Florence with my friend Adina Trufinescu. Make sure you tune in. Hello and welcome to this episode of the AI Show. We're talking all about next generation computer vision capabilities with Project Florence with my friend Adina Trufinescu. Hello, Adina. How you doing, my friend?
Hey, Seth. Thank you for having me.
Oh, so tell us who you are and what you do. We've had you on before. It's been a while, though.
Yeah, I know. It's been a while. So, Adina Trufinescu, product manager, Azure Cognitive Services for Vision. I've been in this space for 4 years now. We've had a recent release, so I'm super excited to be here.
Now, it's not just a recent release. It's pretty exciting. I've been hearing all about this thing called Project Florence. Is this the release? Can you tell us a little bit more about it?
Yeah, for sure. So, I guess the audience knows, for the past 2 years, the AI industry has moved towards large foundation models. So by now, everybody knows about ChatGPT. You've heard about BERT and DALL-E. So this is the first time when Cognitive Services for Vision is launching a large foundational model. The code name is Florence. There are research papers published on this. You can look it up. This is a large foundational model trained with a massive amount of data, billions of text-to-image pairs. It is a multi-modality model, meaning that it's both language and vision. And because of that, it enables new tasks in the vision AI space. So basically, these are the things I'm going to share later, but something like text-to-image retrieval or dense captions. So basically, the language capabilities and the vision capabilities are merged together in this new foundational model.
So how do these things actually work? And now you brought a slide, and I want to make sure you explain this, because I think for those that are hearing about large language models, when we talk about multi-modal models, they're a little bit different. Can you explain them to us?
Yeah, so think of it this way. Before, to train a model in vision, you would find like a data set for that particular task. So if you want to train a model for object detection, you label the data for object detection, and you train a model which is pretty much like specific to that task. And then for each task, you'll have to train an independent model. Whereas now with the large foundational model, you train the large foundational model once. So this is where you bring like the large data set, the large training data set, and then you train the foundation model. In this case, the foundation model for Vision Project Florence, it has both a language encoder and image encoder. So this is where the language and vision capabilities are being, come together. And then you train adaptation models. So these are adaptation models which are fine-tuned with additional data for the individual tasks. So the individual tasks that we show here are classification, image retrieval, object detection, segmentation, captions, and then coming in the future, we have like a bunch more that are going to come in the future. So the idea here is that you train the large foundation once, and then you adapt it for the individual tasks.
I see. So help me understand this, and because this is the part that sometimes is confusing, at least to me. When you're training a multimodal model, and I have some training in machine learning, my understanding is that when you're doing machine learning, there is like the right answer, and then there's like the input, and you're trying to minimize a loss function over those things. What does this look like for multimodal things? Because it has language and vision. What is it calculating a loss over in order to optimize its parameters?
The data set is image and text pairs, meaning that you go and find the data set where the images also have not labels, but they have the description of the image. And then basically the image to text pair is pushed through the training process. And this is where we have contrastive learning, which is like another form of like self-supervision learning. And basically in this process, to train like a vision and language model, this is where a language encoder and an image encoder are being trained, such that you can push like the images and text through the same model. And then this is where you bring together like both capabilities of language and vision.
I see. So basic, because I don't know, in my narrow thinking, it's like, oh, we have a single problem and we're trying, but now these foundational models are learning separate encodings, but then they're putting them together as they go through the optimization phase.
Right. And then that's why the adaptation models come in, because the large foundation model is good at like zero shot, like this broad range kind of things. But then if you want to have like high accuracy for very narrow tasks, that this is where you do additional fine tuning of the large foundation model. So if you look at this image, you have the training data, which is like the massive training data that you train the foundation model. You have the foundation model itself, and then you have these adaptation models. And then these adaptation models actually produce the individual models for the tasks above.
I see. So it's basically the large foundational model has a joint latent space with these two different modalities.
That is correct. And then, in the fullness of time, what we're striving for is like full modality. So when you're talking about you're talking about images, right? So images are pretty much like language and image, and then you have that dual modality. But then when you bring in video into the picture, this is where you have like this is where your true modality, comes in.
I see. And that makes a lot more sense, because like, I think for some reason I heard the adaptation models and I just heard that way too fast. You're basically training the base model to understand images and text at the same time. And then you're using the adaptation models to specifically go to a task.
Right. And then some tasks were not possible before. For instance, when we have a new task for, we call it text-to-image retrieval, and this enables like finding similar images with a text query. That was not possible before because you didn't have like a language model and you didn't have the multimodality.
I see, because they're now in the joint space. If you're typing some text, give me all the elephants, it's able to know about what a picture of an elephant looks like with those words, kind of thing.
That's right. So think about like you push the words to the language part of the model, the language encoder, and you extract vectors in a vector space. You push the images through an image encoder. You extract the vectors in the same vector space, and then you find the cosine distance between vectors, and this way you find similar images.
Absolutely brilliant. I'd love to see some of this stuff in practice. Do you have a demo of what this looks like for people that don't want to? I'm a fan of the latent space and vector math. I'm a huge fan. But for people that just want to use this stuff, how could they do this for their business?
So this is where Vision Studio comes into play. So I'm going to show you that. So if you're familiar with the studios for cognitive services, we have a speech studio, we have a language studio. This is Vision Studio. We are very happy that you can actually use it. I'm going to show you in a minute. And you can use it as a signed in Azure user for more complex tasks, but you can actually use it without even being signed in. So let me show you what it is. All right, so what you see here is Vision Studio. And you can see the features are organized by type. So you can see optical character recognition, spatial analysis, image analysis, and under the feature task, the feature tab, you can find here like the latest things. And let me start by showing you image captions. So image captions, we had this for a while. Image captions, we reached human parity in 2020, but with the large foundation model now enabling image captions, like the quality of image captions continues to improve. So I'm going to show you a few samples with the images that Vision Studio already has here. So we have a group of cows gazing a field. Let me click on this one, a man holding a surfboard on a rock. So this is the image description of the picture. The reason why I'm showing you this is because we have now dense captions. So let me take you to the tab. And dense captions is basically providing you not only the caption of the full image, which is what this one is doing here, but it's giving you 10 regions inside the image with their particular description. So think of it as, if you think about like the object detection, this would be like object detection with labels of objects. But in this case, it's giving you regions inside the image and it's giving you the description of the image. So we call this
the model is the adaptation model doing that all on top of the large model without
yeah that is correct. So this is an example of an adaptation model for captions and dense captions.
That's cool.
Cool. All right. Let me show you one that I love. I'm really I'm really excited about this one. This is the text-to-image retrieval. We call it image retrieval. The actual scenario actually is like searching for photos with natural language. This is where the open vocabulary capabilities of the model come in because of the amount of training data that goes in the model. You pretty much like can search with anything. So this is where the language, the natural language capabilities come in. And we have here a set of sample images that we provided for you to try with. If you're not signed in, you'll be able to try with these images, and then you can bring your own. So I'm going to show you like how to bring your own. But first, let me pick one of these. And what we did here, let me position it. We are giving you a search query example just for you to see like the kind of things that you can search for. And then you can also bring your own custom search query. So let me pick like a few of these. We have employee wearing a white safety hat. So you can see here like the top 10 results. And then see this slider here. Mm-hmm. The model, when it's looking for similarity in the vector space, the vector space is broad and is calculated based off all the images in the set.
Right.
So if you want to see like the most relevant results, this is what you do. But if you want to see like, all the search results, and then you can pick your like whatever, relevance, you are comfortable with. So this is how you play with it. And notice here, like, as the images are ranked here based on similarity, you'll start seeing like the results which are not exactly what you are searching for, but still within like that similarity space.
That's cool. And it's all based upon that same model, which is absolutely amazing. We used to have to train like a ton of specialized models for all these things, and each one needed to be babysat, so to speak. It's cool that you're able to do this all with one large model and some tiny adaptation models.
Yeah, that's right. So the other thing that I want to show you here is you can bring your own search query. So the one that I want to show you here is person driving a forklift, which is within the realm of manufacturing. So you can find here like top search results, like you can see people driving forklifts. So whether you try something that we suggest or you bring your own thing, then you can do that here. And like I said, you can bring your own images. So you can try it with your own images. So you can bring your collection. I already have my collection here. These are my personal photos. So you can see like my dog and things which are going on here. So let me show you like a couple of things. So let me come here, and then I'm going to say white dog, which is kind of an obvious one. So you can see like my puppy being displayed here. But then the model, I told you that the model has been trained with this like huge amount of data. It can reason with external knowledge, and it knows of things. So it can find things which, even if they are not labeled, you can find them. So I'm going to give you an example, and it's going to be obvious. So I have a picture here in my data set. Let's see if I can find it. Let me reset the search. And look at this picture here. This is the picture of Horseshoe Bend on Colorado River. Mm-hmm. Okay. So you can search here with Colorado River. And you'll notice like the first, similar image, the top result is actually the Horseshoe Bend on Colorado River. And this requires like no metadata, no GPS information, and you will find this kind of thing. So you can say Bryce Canyon, and then the model will know to find the images coming from Bryce Canyon. And then the last one that I love is Mount Rainier. And then it's going to find the pictures that I have, with my hikes on Mount Rainier.
And this is, I don't think people, if I'm understanding this right, these are just random pictures that you uploaded into the system. You ran the search query without having to do anything. The model was able to do all of this searching without even having to specialize.
That is correct. So basically, what you come here and then you can try it yourself. You bring your images from either your blob storage or your local disk. The images are actually, it will take a little bit of time because each image is going to be pushed to the model to extract the vectors for each image. And then think of it as you have like an index built for your set of images. And then you come with the text query, and then the text query is going to be pushed through the model. We extract the vectors from the text query, and then every time when you click search here, we calculate, the similarity by doing cosine distance between the vectors of the text and vectors of the images in the dataset.
And the relevance just basically widens the angle for the return result, I'm guessing.
Exactly, yeah. So basically, look at this one. Like if I say most relevant, you'll notice here that each image has Mount Rainier in it. If I move the slider, you'll see things coming in which may or may not be. So you see what I mean? Like, the similarity, this is where you come in, and then as you build your own, as you start using the APIs, and as you get these kind of results, you'll have tolerance. Different users and different use cases have like different tolerance for the similarity. And we don't cut off to like some number of results. We give you like the full similarity, and then you decide what's relevant for you.
That's cool. So is there any other aspects of Florence that Project Florence you wanted to show us before I ask another obvious question that's coming to me?
Let me show you the search capabilities on video. All right.
Oh, wait, video?
Yes. So let's talk about video for a minute because this one is interesting. This is a demo for how to do frame locator and summary on videos. And I have here sample videos that we provide for you. And then same as before, you can try it with your own video. The problem with video today is that there are many cameras deployed on physical spaces. There are petabytes of video that are being stored every day. But imagine having to search, video footage for events of interest. Like it can take like, if there is a security incident, for instance, it can take like hours or days to actually find the incident in like video footage. So this is where video summarization and video search, or rather frame locator, comes in, where you can actually, take a video snippet, run it through summarization, see a summary of what's going on, and then get some idea of like the things that are happening, and then the things that you can search for.
That's immediately useful just for editing a video, for example. If I could say, oh, I remember when Adina said this thing, and I just type it in and it can go to the frame, that would be really cool too. That
is true, but with the correction that it's not when Adina said something, because we are not processing audio yet. It's when, Adina did something.
Which is even harder to, because I mean, processing audio, you can get the text out of, but it's like, oh, she showed me this window that had this, she showed me apples, and then it would go to the frame where you're showing me apples. It's basically what you're saying. Am I getting this right?
Yeah. The same idea of like finding similar images. So think about videos as collection of images. It's just that they are organized in a video stream, right? So same as before, when you come in with a set of images, now you come in with a set of frames. We sample a set of frames from the video, and then we build a summary, and then we build the search index by collecting, extracting the vectors from the frames. And then same as before, we can do like text similarity between the input text and the video frames in the video.
All right, let's take a look at it.
All right, so I have like a bunch of things, but I'm going to choose the data center one. So this is a video of people doing things in a data center, where, some things should be done, some things shouldn't. So I'm not going to comment on that. So basically, you can summarize this video, and then you can see here the things that are happening. And what we are doing here, we are trying to highlight the interesting things that are happening, such that can give you an idea of like what to search for. So we have here the summary, and then the interesting events with a person seeing running, a person seeing falling, unattended backpack, workers showing climbing ladders. So now you can come here and then you say locate specific frames. And same as before, we give you ideas what to search for, but let's search for the things that the summary told us that they're happening. So we have person climbing a ladder. So let's see what it finds. So basically, it found like multiple frames here. So you can click on the frame, and then you can see the frames where the person was found. You can click show more, and that's going to give you like additional frames. We had one with person falling. So let's try that one. So there we go. It found it. And then same as before, you can see the multiple results. And let's pick one of these ones here, person with a laptop. There we go, person with a laptop walking through. So you get the idea. So basically, you have the same idea as before, except now that you are finding frames inside videos.
That's awesome. And it's cool that once you understand the basic knowledge of the foundational model, how many adaptations there are is pretty impressive. Now, the question I have for you to follow up, there's got to be some ways to customize these models or the adaptations. Is that possible at all?
Yeah, so the foundation model can also be customized. We offer 2 customization tasks, the most popular ones for image classification and object detection. Mm-hmm. So actually, let me show you these capabilities here. I am going to show you a model that I trained. And to train a model, you need a training data set. So I have here a training data set. I already have the blob storage with the training data. This is a custom model that detects commercial drones. And you'll notice here that in Vision Studio, there is no such thing as a labeling experience. That is because we are now using the same label experience as Azure Machine Learning is using for training Azure Machine Learning models. So yeah, so one of the problem customers complained before was that, with the custom vision service today, you have to label the data in some format. In Azure Machine Learning, you have to label it in a different format. If you want to train models in both services and compare, you have to label the data once. So this is where now you can go into Azure Machine Learning and label your data. And I'm going to show you like the kind of data that we have here. So let's go to the data. And then you'll see here images of drones. So let's see, review labels. So this is an object detection. So for simplicity, we have a single label. It's called drone. So you get the idea here. This is the object detection labeling for Azure Machine Learning. Once you're done labeling, you come back to Vision Studio. You import your training data, and then you train a model. I have here a model which is already trained. So let me click on that. You can see here, let's see if I can bring it up. You can see here the model accuracy, which is determined on the training data set. We have added an evaluation run, so you can evaluate the model with additional data sets. And then the last thing that I want to show you is, if you want to test your model, then this is an object detection model. So on detect common objects on images, here you can select from the pre-trained vision model versus the custom model that you trained with, and then you bring an image and then you run inference.
That's amazing. Now, is this doing like is this changing the base model, or is it building an adaptation model on top of the base model, or what is it doing exactly?
So the foundation model serves as the basis for applying transfer learning. And I shouldn't say the foundation model, the adaptation model above. So basically, an adaptation model for object detection serves as the basis for applying transfer learning, and we have object detection and image classification. So the adaptation model for image classification is going to be the basis for transfer learning for image classification.
This has all been really amazing. Where can people go to find out more?
Well, we have the link on the screen. So Vision Studio, aka.ms Vision Studio. So this is the portal that I showed you here. Go ahead, try things out. This is a no-code experience. And when you are ready to test the APIs. Then we have documentation, and then you can test the APIs as well.
Well, Adina, this has been amazing. I can understand why we're so excited about Project Florence, at least why I'm excited about it. Thank you so much for spending some time with us.
Glad to be here, and very excited about the Vision AI capabilities for cognitive services. Please try it out.
Awesome. We've been learning all about next generation computer vision capabilities with Project Florence on the AI Show. Thank you so much for watching, and hopefully we'll see you next time. Take care.